the bigger question is one of getting society to see the value of having a circular economy. And if we are going to, I mean, there are two parts to it. One is also we need to reduce consumption. I mean, for example, having drinkable water in aluminum cans, even if they're recyclable, is not a smart thing to do. You want to use your reusable water bottle and fill it with a filtered water spot. So there is somewhere where we need to also think about consumption has to decline. But where then we do have to consume and we do need to recycle, then it's a matter of changing consumer behavior, having product modularity, and ensuring that we have the right infrastructure to be able to capture what might get missed.
Welcome to Care More, Be Better, a podcast for people like you who care about the social impact of conscious companies and everyday heroes. Hear inspiring stories from those who put people and planet before profit and personal gain. You'll learn how you can make a difference, vote with your dollars, and get involved today. Here's your host, Corinna Bellizzi.
Hello, fellow do-gooders and friends. I'm your host, Corinna Bellizzi. You know what? In today's world, we are confronted with so very much that we have to contend with in the day-to-day. And one of those things really has to do with the fact that so many of our world's natural resources have been harnessed to make our lives easier, more convenient. Can you imagine the day before you had your computer or a smartphone? It really wasn't always that way. Not too long ago, we developed these technologies. So, have you ever thought about what life would be like if we didn't have metal? Having explored the cultures of prehistoric Europe with a background in archaeology, I've thought about this quite a lot. I even dug a site that predated the Stone Age in France, an hour north of Paris, a tiny town called Longueuil-Saint-Marie. And while there, as I dug in the dirt and found stone tools, I also learned that there was another site just down the way from the Iron Age. And seeing the juxtaposition of people and their remains in a period that was not too far removed from one another, but yet the dramatic shift that they saw in their culture was nothing short of astounding. I felt so honored to be able to experience these things firsthand, to see them, to see a snapshot of what life would have been like before we really had any technology save for a stone tool, perhaps a spear, an arrow. So, as we think about the modern age, about the moments of technological leaps that have really changed everything about the way that we live, and learning to extract things like metals from our environment, precious stones and gems that get used in our technology, the wonder of silicon, the Silicon Valley is named for. I've often wondered about what it takes to really do all of this and how we've got to this point. How have we managed these resources? And could we have been doing it better along the way? How do we do this modern living mindfully? And what are the consequences of doing things like strip mining or mining our soil and our stone? What are the potential benefits and what could they land us in? So I'm thrilled to have a partner for this discussion today, a really great example to learn from too, as we talk about soil to foil. This is an book written by Saleem Ali. He is an academic, a professor, a PhD. And really, this book, Soil to Foil, Aluminum and the Quest for Industrial Sustainability, caused me to reflect so much already on what I thought I knew about aluminum. So let me tell you a bit about Saleem. Saleem H. Ali is an academic who earned his Masters and PhD in environmental policy and planning from Yale and MIT, respectively. His undergrad was at Tufts University, so he's been to the gamut of these Ivy League schools. He is presently chair of the Department of Geography and Spatial Sciences and the Blue and Gold Distinguished Professor of Energy and the Environment at the University of Delaware. And while he has a very impressive academic pedigree, he also shows a great care for our future through the work that he does outside of his academic work with not for profits, a past with the UN, National Geographic, and the World Economic Forum. He has authored many articles and two other books, Earthly Order, How Natural Laws Define Human Life, and also Treasures of the Earth, Need, Greed, and a Sustainable Future. He's truly a world citizen, having been born in the US, having spent much of his youth in Pakistan with his parents, and also becoming a naturalized citizen of Australia. I'm so honored to have him here today. So let me just bring him up to the stage. Dr. Ali, welcome to the show.
Thank you so much, Corinna. Pleasure to join you and your audience.
Yeah, I have to say, I got really excited when your PR agent reached out to me about this book, Soil to Foil, because I have often been an advocate for the use of aluminum as an alternative packaging in the world I work, which is in the natural products industry. So many supplement companies, they just go straight to the Boston round plastic. Let's put it out in plastic, 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 right? Glass is expensive, it's breakable. And why haven't we thought of aluminum? But the things that come up as I have confronted that have been like, "Oh, well, what about the coatings in the aluminum, and how is it really when it comes to environmental impact, and are we sure it would be recycled?" And a lot of this is answered in your book. So, before we really dive into that depth of conversation, I would love to just learn a little bit more about what inspired you to write it, the 160 countries that you visited in your time on this planet, perhaps how some of that influenced the work, to really just offer you the floor to talk about that because this book is one part history, one part chemistry, and a lot more too. So I just I know that even though it's only what about 250 pages, it's 250 pages of really a story. It's a story and it's technology. It's so much.
Great. Thank you, Corinna. Really appreciate your interest. My journey has been through chemistry in terms of my first degree was in chemistry. So I've always been interested in the elements of the earth. The periodic table has always fascinated me. And that's how I started on my intellectual journey in college. But then in terms of my temperament, I'm much more of an extrovert. I love meeting people, traveling, and so on. So I didn't see myself in terms of my career spending time in a lab or doing just experimental work in chemistry. So I ended up doing graduate study in environmental studies, environmental planning. And this book has been a way for me to connect back to the elements while still retaining that panoramic view that now informs much of my environmental science work. And the journey started partly because the publisher, Columbia University Press, they had expressed an interest in a book that would be a deep dive on one element. And the editor at the press, who had read some of my earlier works, particularly Treasures of the Earth, which was a book about our relationships with minerals more generally. It was a book about sort of wants and needs for minerals. Uh, the editor, she asked me to think about one element where I would do a deep dive. And I thought about what other books had been written, what other elements had been explored. There are books on uranium, lots on gold, diamonds, and carbon. But on aluminum, very few books which do this kind of general audience coverage of the metal and how it is so interwoven with our lives. And there was one earlier book by an academic, which was titled Aluminum Dreams, Mimi Scheller. And that book was much more sort of a critique of the whole aluminum industry, a very good book, but it didn't provide the kind of the kind of industrial context of contemporary aluminum products that we might want to think about and how we should plan for the future in that regard. And so that's where I decided to focus on aluminum. And so this book has been essentially that um, a personal journey as well as an intellectual journey, trying to think through our relationship to the element. And my travels have informed it because whenever I'm overseas, I often think about at every point, aluminum is is with us. The airplanes we travel in are largely made of aluminum. Even the ones now, the new ones with carbon fibers, still have a lot of aluminum. The computers we are using, as you noted as well, so much of the consumer products we use, beverage cans, foil itself, it is ubiquitous, the most widely used metal. And it's also a metal which, until about 130 years ago, was very difficult to harness. So it presents this unusual combination of something that's very common in the Earth's crust. It's the most abundant metal in the Earth's crust, but it was so difficult to extract it because of its chemical properties that we weren't really able to you fully utilize its chemistry. And then once we figured out one issue, one puzzle of how to extract it with economic efficiency, it just opened a whole world of products for us.
Right. Well, I'm holding up a bottle that I helped to actually develop. This is Orlo's immunity spray, right? Like, it's coated because they all are. But, this is food grade, so you have something produced like this for a spray bottle as opposed to plastic, or they're even doing shampoo and conditioner bottles like this now. Or, I was actually looking at another one right here. It's just part of project. You can see it's got a sample number on the top and everything. Just like thinking about tea jars or things along those lines, ways that aluminum can be used, with one of the arguments for its use being its imminent recyclability. But to your point, it's expensive, uses chemicals to extract, and has impacts on the environment. So, can you talk about what the present state is? Because while we could enjoy a history of what it takes to get out of the soil, where we are today, I think is more practical. We can always point people to the book for that. But, you know, how difficult is this to extract now? What sorts of waste does that create? And how do we handle that? And then also, I'd like to kind of take from that perspective, segue to talking about recyclability and perhaps how we could ensure that we develop a more circular path for aluminum so that it ends up in circulation longer and not wasted.
Yes, certainly. So currently, aluminum is largely extracted from its primary ore, which we call bauxite. And bauxite occurs in many parts of the world, but for economically viable extraction, it's available in some very particular deposits. And the world's largest bauxite reserves are in the African country of Guinea currently. And geologists use this term reserve, which is basically what is economically viable to extract, versus resource, which is what's out there but might not necessarily be viable to extract from an economic perspective. So Guinea, unusually, is a country which has this enormous reserve of bauxite. Australia has very large reserves. The Caribbean historically had very large reserves of bauxite ore. And these are, accidents of geology where these minerals occur, which is one of the other fascinating aspects of looking at the extractive industries, is that unlike a factory, which you can just put anywhere, a mine can't just be put anywhere. You need to think about exactly where the deposits are. The reason why it took us so long to extract aluminum is because it forms very strong bonds with oxygen, and it's really hard to get the metal out. Aluminum metal does not exist in nature on its own. It's always combined with other elements. Unlike copper, for example, which you can have native copper, and Upper Peninsula of Michigan had actual curtains of copper you could find, in some of the mines. Yeah, you had veins, you had, exactly. So you could get the metal. With gold, you also have that. It occurs on its own, but you do not have that with aluminum. So that means you need a lot of energy to extract it. And you need certain other catalysts which will assist the process. And one of those catalysts is what allowed us to upscale. And that was this mineral called cryolite, which once it was discovered by an undergraduate student at Oberlin College in Ohio, which is also a great story on its own. That really transformed the whole aluminum industry. And so now aluminum is mined in many parts of the world. There is a much greater emphasis on recycling because it's also economically viable to recycle aluminum, given the fact that the energy cost is so high for the smelting of bauxite. So we've got now a lot of recycling efforts underway across the aluminum industry as well. But still, mining does dominate all over the world. And China and Russia also have a major role in the aluminum industry in terms of extraction and refining. So that has complicated the geopolitics also of the metal. But yeah, it is a fascinating metal in terms of its availability and then the ways in which it can, down the road, contribute to a circular economy.
So if we think about aluminum, the last statistics I had looked at said that something like 70% of aluminum in circulation was getting recycled. But in your book, I learned that it was actually closer to 50%. And that when we compared it to things like tin cans or other sorts of metal cans, that they have higher recycling. And of course, that I think batteries were at the top of the list. So things like your car battery, where if I return my car battery, I get $15 back. And so that's what incentivizes the consumer to not just dump it, right? Um, we don't really have a viable incentive program in place for things like the aluminum products that we produce in the day to day anymore. I think in California, it's done by weight. And of course, aluminum is pretty light. Um, Most of the can recycling gets done either from people in home or, from homeless people who still do go and source it and turn it in a recycling center. But with the payout no longer being 5 cents a can, it means that I think that's also dipped. What ideas do you have for how we can improve recycling participation, specifically as it relates to aluminum?
Yes, so with any recycling program, the challenge is one of dispersion, or what we may say entropy of the waste, and if you were thinking in physical terms, and then also the modularity of the product and how easily you can extract it from an existing product. Now, with aluminum, with some of these products like cans, you can, they're all in one place. The aluminum is right there, so you can recycle them very easily. But if you have aluminum in a computer laptop, it's more challenging because you have to detach it. You need someone to take out the material. It's more labor intensive. So this is the challenge with aluminum, is that you have such a vast amount of products and you've got a lot of dispersion. Like foil itself, which is the title of the book, it is recyclable, but how many of your sandwich wrapper foils get thrown in the trash? They're not, it's very rare that people are going to recycle foil that they're using for their sandwiches, right?
Well, they get rules too, like it varies by municipality. In my municipality, I'm supposed to compact the aluminum as much as possible and then throw it into the bin. So if you've just got a little bit of, foil around your sandwich and you're out and about, there's not a recycle bin. What do? You pack it home. That's what I do. I pack it home. But I realize that I'm the rare person who even has gone as far as traveling to a trade show with an empty suitcase to bring back recycling when I knew that the trade show I was going to didn't support recycling. Now that's gotten much better. The landscape for that has gotten much better in the industries as a whole. However, even just going over the hill to San Jose and visiting my in-laws, they recently took away their recycling bin and said they're throwing everything in the trash can now. And it's because the municipality has made the choice to remove the recycling bin, not because they chose. This is Silicon Valley. I mean, I'm like, really? They're taking away your recycling bin? And it's like, well, we're trying this now. We just have the garbage bin and we have the yard waste, and that's it. So to learn that we're having these kind of walkbacks in certain arenas, it's partly because recycling is difficult and there's a lot of rules and people can't be bothered to learn them. So they're throwing things in that are not recyclable into the recycle bins. And then that creates a cost center for the city to have to deal with it. And so therefore, I mean, in the end, they've thrown up their arms.
Yeah, I mean the single bin recycling has actually been a big problem in this regard because And the plastics industry has to share some of the blame with it, because by putting those recycle labels where it appears you can recycle almost any plastic, but in effect, it's not economically viable to recycle many of those labeled plastics. So people just throw them all in there, and then the waste companies have to take out all that junk. And that has made it very difficult. So I think with the aluminum, especially with metal recycling, we need to have, I think, much more differentiated waste streams, bring back the deposit incentives. That is going to be where we will start getting back and meeting our targets of maybe with cans it should be 80 to 90% target. I mean, there's always going to be some leakage in the system, but it should very well be in that space. And then of course, for the large scale metal uses of aluminum and aircraft and all, there is pretty good recycling. But then there's also, upcycling versus downcycling, where you want to be able to have the aluminum available in at least the same kind of use, rather than having to recycle it into a product which is not going to be of the same value, and you'll still need to mine for the others. So it's a very complex question of where we draw the line of having these various recycling programs and actually having a functional circular economy.
Yeah. I watched a program years ago. I think it was put out by How It's Made on aluminum foil. And in that video, they had shared that something like 99.9% of the recycled aluminum is essentially reusable. Like there's very little loss in the recycling of it. I don't know if that number is accurate, frankly. And I can't remember if I came across a statistic like that in your book. But, if it is so eminently recyclable and reusable, and there's an economy of scale associated with that, and it's environmentally expensive to extract the aluminum from bauxite, it makes no sense to me then why we wouldn't have incentives in place to make sure that we're utilizing this because it's 90% more efficient insofar as environmental energy is concerned, right? I mean, that's the statistic I do remember seeing in your book, 90% more efficient.
There is no doubt recycling is far more energy efficient. And So it's really the bigger question is one of getting society to see the value of having a circular economy. And if we are going to, I mean, there are two parts to it. One is also we need to reduce consumption. I mean, for example, having drinkable water in aluminum cans, even if they're recyclable, is not a smart thing to do. You want to use your reusable water bottle and fill it with a filtered water spot. So there is somewhere where we need to also think about consumption has to decline. But where then we do have to consume and we do need to recycle, then it's a matter of changing consumer behavior, having product modularity, and ensuring that we have the right infrastructure to be able to capture what might get missed. And technologies are improving, like Norsk Hydro, for example, which is a major company that processes aluminum in Norway. They have developed really advanced laser techniques and all to be able to take out aluminum metal from complex waste streams, and that has helped them improve their recycling percentage. So technology can certainly help too.
Well, I was chuckling there because I think the only way I get my husband to drink water is really because we have all these soda waters in cans available for him. And I mean, we do refill and we mostly do that. But even though we have a soda stream, I don't know if you know what these are, but it's like, to make soda water, we'll get to a point where it's like the canister that we have to then replace, and it's like an exchange replacement at the local chef shop that we do because, again, reducing waste, right? We like exchange the old can, get the new one to refill the CO2. One more thing we have to do. And so the soda stream sits there not working for 6 months and we just consume the cans. So even being, I would call myself kind of a dark green person where I'm like constantly working on reducing my waste, our soda cans are definitely an arena where we produce more than I would like. But that being said, we're not consuming a lot in other arenas. So I think being mindful and understanding that no person's going to be perfect. And heck, if you can recycle something, please do. And if you can recycle something, please do. So, yeah, this is a complex question. The other question this leads me though to talk about is this continual use of having to coat aluminum and the health risks that people proclaim are associated with that. Like, for instance, bisphenols or bisphenol F, I believe, is what's still used. If what you wrote in your book is, I think that's the last thing I read. The bisphenol F, while being less toxic than the A and some other forms, it's still used. Is there another option for us to coat the aluminum so that it can safely be used for things that humans can consume?
Well, I mean, that's one of the reasons why you have aluminum sodas and all that. You don't get hot beverages as much in aluminum also because you have the coating of the plastic. Most people don't even realize it's there, but all of aluminum cans have this thin plastic coating, very thin, because otherwise the aluminum would corrode with the phosphoric acid and other chemicals which are in the soda. That also has carbonic acid in it. We put carbon dioxide in water and it forms an acid also. So basically, there right now there isn't really much in terms of an environmentally efficient and economically efficient alternative, but we do have now enough of a uh, timeline of studies that show, I mean, there's no major disease outbreak from this, so we have to keep things in perspective. It's not like, this is causing huge cancer clusters or anything. There's no such evidence for that with the use of the cans, but it is an additional material that's being added. The use of aluminum in terms of cans is primarily that they're very light for transport. It's easy compared to glass, and it's very robust. So those two factors are why it's used. So you reduce the carbon footprint of transport with the weight being less, and they're very robust. They don't break, so you get your product there. With glass, you need more packaging. It's heavy, and so that's the real challenge. Then you have the Tetra Pak, which is the other option for beverages, but Tetra Pak also has a thin layer of aluminum in it. They have plastic and they have paper, but I mean, Tetra Pak, I think, is very important from a public health perspective because it has allowed milk and dairy products to be carried at room temperature in developing countries where refrigeration would not be possible. So to have UHT milk, which is in Tetra Paks, and if you go to a developing country, you do not get milk like you do in US grocery stores in a big jug.
No, I mean, and even in Europe, it's very common. So, like, the first time I really got exposed to the Tetra Pak for a milk product was actually in France at that archaeology site because they would buy the milk and have it on hand and not have to worry about whether or not it was going to spoil because we're in like what I would call a mobile, like temporary housing structure to do this archaeological dig. Refrigeration is tough. You don't necessarily have the right kind of electricity when you're working on a generator or things like this, right? And so you're living in this kind of minimalist way anyway. And so we had that kind of milk there, which is a little surprising to me in France, right? But then now you see that the ubiquity of that style of packaging has come through in a lot of other arenas. People will be most familiar with it from things like coconut milk or oat milk. Like if you go to Costco and you're buying, oat milk in these six packs, it's in that style of packaging. But they're also not necessarily as eminently recyclable. Like in my neck of the woods, they're not really. Like I would have to pay to ship them in a cube to somewhere else that specializes in handling these materials to recycle them because they're multi-layer, because they have paper and plastic and aluminum in one. So there's an environmental effect to this as well. I also connected with another prior guest from boxed water to talk about that very issue because their boxed water is better, right? Like they actually made the argument that putting Aluminum cans in circulation for water isn't necessarily great either because there is some environmental damage when they're left in our oceans because of the bisphenols. And I'm just like, "Oh my gosh, is there no thing that's safe for us to get behind using?" Like, at a certain point, we have to say, "Okay, this is better than plastic," right? Like, we're finding microplastics essentially everywhere. The fact that it's so recyclable, that it has economies of scale, that it can be mindfully used, that the can then become machined aluminum block somewhere that's then used for something else could become the computer skin on your Apple computer eventually, if we're smart about it.
Yeah, no, absolutely. There will be trade-offs, and with Tetra Pak, I think the benefit that it's provided with access to nutritional dairy products in countries, communities where they wouldn't be possible without refrigeration, that's a huge benefit, and it outweighs the potential, I think, challenge of recyclability there. And plastics, certainly there is, with PET, plastics are very recyclable and they're very light. So for certain, I mean, that's why most of the water bottles we get in the world are PET plastic, because they do have the advantage of the aluminum being light, and at the same they're robust also, and they're very recyclable too. So there's a trade-off between plastics and aluminum, but then it's a matter of whether the plastic is actually going to be recycled. Now that's where, again, the challenge happens with the pollution in the oceans and so on. If we are able to have recoverability of the plastic, then that gets taken care of. But then there are the carbon factors with that also, because you've got the plastic requires fossil fuels. The fossil fuel companies will tell you, well, but you're actually sequestering the carbon in the plastic, that once it's made, it's not being burned. But it may well be that if it's not recycled, it's going to be burned. So it's very complex. It's what we call, and then I discussed this in the book, that it's a complex socio-ecological system, and it's like a memory foam. You put your hand here, something else is going to come up here, and it's very difficult to navigate that. But we have metrics. The good news is we have tools like life cycle analysis. We have very good data acquisition tools now, which can help us process all that information much better.
Yeah. Well, I wanted to dive into one of the topics that you do feature in your book now, and that is Mr. Aluminum. I didn't know there was a Mr. Aluminum. But in your book, you also detail he's talking about things like Alzheimer's with regard to aluminum. And this is something that has come up, I think, more as we have an aging population. My in-laws are in their 90s officially. So, we have people living a long time. And when people live a long time, they develop things like plaques in their, you know, tissues, their soft tissues, and even in their brains, which can affect their long-term health. So what is the connection between aluminum or aluminium, as the Brits like to call it, and Alzheimer's?
Yeah, so there's been a huge amount of writing on the use of aluminum in antiperspirants, particularly because the one of the original uses of alum, which is one of the salts of aluminum, going back even to the Roman times, was as an antiperspirant, and so there's been this um, whole line of research which suggests that if because aluminum itself is not metabolized, and this is one of those very unusual features of aluminum, that it's so abundant in the Earth's crust, but no living organism has developed a way to metabolize aluminum. So, like iron is metabolized. We have iron in our blood. Hemoglobin is iron, and so it's in. But even though aluminum is more abundant than iron in the Earth's crust, life didn't evolve to metabolize it. So there are a group of scientists who then use that as a way to say, well, there must be something wrong with aluminum, that it hasn't been metabolized, right? And but if you look at the toxicology of aluminum, it's not so simple. It's not like lead or cadmium, where we know very clearly that the lead and cadmium get metabolized in a negative way, and they actually mimic molecules and they confuse the body, and that's what causes their toxicity. With aluminum, it just passes through generally. And there are very few cases where it will mimic some other molecule. So if it's just passing through, then it's probably not that dangerous. And that's why there is so much controversy over it. But there are a few of these researchers who have been. There's one particular British researcher whom you were referring to, Christopher Exley, and he's very well intentioned, I think, and has written a book about what he perceives as very serious health issues around aluminum. But in terms of the larger consensus literature on this is that there may be some concerns, but there isn't any kind of definitive linkage of toxicity of aluminum products and linking them to Alzheimer's or to, in other cases, he's also linked them to cancer and so on. But the research should continue. And I think with any scientific project, I would never say no. But at the same time, the data we have thus far, and we have now such a long track record of use of aluminum products, that I think it's fair to say that um, and there are so many other carcinogenic compounds in our daily lives which are much more well known to be carcinogenic, like alcohol, for example, which people for other reasons are not going to give up, perhaps. But the data on alcohol carcinogenicity is very clear. WHO has also been very clear by that point. So I think we have to look at it in that bigger picture.
Yeah, I'm in agreement there. And, if aluminum doesn't really interact, then having us, use it in something like a can for a beverage to me doesn't sound like it's the end of the world. But there was some background with regard to using heat with aluminum. And so things like aluminum cookware, generally speaking, that's all coated. But, in your home, knowing what you know, would you use an aluminum pan for cooking?
Yeah, I mean, we have used aluminum cans. Growing up in Pakistan, they were very commonly used, and they still are. And there was like homeopathy has always said that we shouldn't use. So you have doctors who are homeopaths, and they'll say never use aluminum for cooking. But if compared to iron, I mean, yes, aluminum is not going to give you the benefits that cooking in an iron uh, kind of utensils would, because there actually you need iron in your body. So if it's leaching, it's actually going to be useful for you down the road. So to a certain point, yeah. You don't want to get anything in excess is dangerous. Even water is dangerous in excess. Um, but yeah, I wouldn't be worried about cooking in aluminum cans, which in aluminum cookware, which has um, not been coated with any plastics and all. Of course, but they wouldn't.
But most of them, they're all coated in things like, you see all sorts of things now coating them. They'll say they're ceramic, but they also have another layer of something that's anti-stick, and that anti-stick thing could have nanoparticles in it that end up in places you don't want and that do disrupt your hormones.
Totally, yeah, that's a different story, the non-stick story. I'm talking about just an iron, an aluminum pan with which will have a natural coating of aluminum oxide. Automatically, it will form that. But then, and sometimes they have other kind of alloys also, which they will include.
Yeah. Something else you revealed in your book, which I did not know that tin was its own element.
Yes.
I thought it was an alloy, and so I thought it was aluminum and something else.
Bronze is an alloy of iron and tin. Yeah.
Yeah, so I mean, it's just you get used to the colloquial use of the word like a tin can. I don't even know if most tin cans are made of tin anymore. So, the imminent recyclability also of tin means that yes, you can put your canned goods in the recycle bin, even if it's not aluminum, it's still going to be recyclable, right? Yeah.
Yep, absolutely. And most of them are, yeah, most of the current tin cans have other metals in them for sure, but historically.
Since you spent so much time kind of looking at how industry uses aluminum, I wondered if there were specific uses that you thought that we should be looking to for aluminum that respect its unique properties, the fact that it can withstand heat, that it can be, stable and solid, that it can be machined to be thin enough to be malleable like an aluminum foil, that it can package things like foods. What do you see as the next potential usage of aluminum?
Well, in batteries, I think that would be the really next big thing because, for the green energy transition, if we're going to use solar and wind power, we will need huge battery storage capacity because for any kind of electricity delivery, we need baseload power and we need then other additional sources which can provide, peak load. But the base load power, wind and solar can't provide, and you always need to have some battery storage for that. So, and as well as for electric cars and so on. So, the next big thing will be if we can start uh, making batteries using aluminum. And there's a lot of research going on. And I mentioned in the book also some of the research around aluminum batteries. Um, because then it's a very abundant metal. We wouldn't have the kind of problems we have with cobalt and some of these exotic metals which are more difficult to extract and they're in distant places. So I think that's going to be the next big thing for aluminum if they can devise batteries.
It's relatively lightweight for the space it takes up, right? So I could see that being a potential application even in electric cars if we could advance the technology enough. So much of the research for things like battery storage is around things that are, yeah, they're going to be heavy, but they'll be fixed, so it won't matter as much. I've seen research into calcium and the other minerals that are abundant for that. So it's possible that that will end up being some sort of a combination technology long term.
And having sodium instead of lithium, and then having aluminum in terms of the electrodes, and that could make things very different because right now the challenge we have is also that lithium is very rare. The lithium ion battery is the most widely used. And then the electrodes for that battery are cobalt, graphite, which is also very difficult to extract, as well as to even to manufacture. You need coal to make graphite if you make it synthetically. And then you have some of the other kinds of metals are also magnesium, nickel. These are very difficult also. So if we can have, and they're heavy, so aluminum batteries, which combine, other materials, iron phosphate. There's a lot of research going on around that. So you have lighter batteries, but it is complicated chemistry because you need the battery to have storage capacity. You need it to have discharge that's going to allow you to be able to charge at rapid speed. And you have the weight problem. So all of that has to come together, but there's a lot of research going on it, and it may win a Nobel Prize in physics in the future or chemistry.
Yeah, well, perhaps some researchers will be involved in that. So, given that it's the most abundant metal that we have at our grasp, it's still hard to extract, but eminently recyclable. I wanted to talk about for a minute where we've created problems with extraction. You highlight a couple of examples in your book, one of which was in the country of Jamaica with the bauxite
Mhm.
mines there and how it impacted their environment. And then another of which was not necessarily in the aluminum space, but equally talking about extraction and how we handle resources between Haiti and the Dominican Republic. So I'd love for you to talk about some of the perils that we've experienced in the past and how we can avoid those in the future. And also, then in the space where we might have a mine and we want to return the earth to a more natural state after we're done with it, so to speak, how we might do that.
Yeah, sure. So, aluminum, the history of mining aluminum in especially the early part of the 20th century is a very checkered one. A lot of the aluminum came from the Caribbean and also from parts of Canada. And there was also big smelting operations in Canada, particularly because the hydropower was cheap. So we have the history of Jamaica, particularly with the aluminum industry there having a huge impact on farmland. And for communities who were dependent on agriculture, the farmland was destroyed, and it was very difficult for any restoration to be done. So that we have to learn from that, and the industry is trying now that they have remediation plans when they go into a bauxite mine. In Australia, there are some very good examples of some of the new bauxite mines which have had a good relationship with indigenous communities. I mentioned in the book one particular bauxite project which was going to even have joint ownership with an Aboriginal community. Um, so I think the tide is turning from that darker history of extraction, and that was true of a lot of minerals, but not just minerals. We have terrible examples of colonization, which was done for the spice trade, for chocolate, for cocoa plantations, for sugar cane, for so it's a huge.
You could just create a laundry list.
Yeah,
Yep.
exactly. But we should learn from that definitely, and I think the industry has come to do so.
That's fantastic to see. The example you include in the book from Jamaica, I believe, where the farmer took some of his soil and sampled it and wanted to test it to see if it would be good for growing grass to graze his cattle. And the UK took over, the crown took over the land for its mineral rights because of the aluminum present.
Exactly. Yeah. Yeah. He was going to, as soon as they found out it had a high bauxite content, they just put forward.
Never mind, you can't grow grass or graze your animals on it. We're gonna take it over because we own the mineral rights. Ugh, I wanna see all of that go the way of the past, but as we know presently, you even have those sorts of issues on indigenous lands in America where they wanna put a pipeline through for oil, and fracking, and those projects continue to move forward even when the general population doesn't want them to, even when they are going across, tribal lands. And so there's it feels like in some cases it's 2 steps forward and then 2 steps back, but it doesn't mean we should stop. Okay, so there is certain toxic waste that is created through the mining of any of these minerals. So there's two major byproducts that come with aluminum processing. There's the 1.5 tons per ton of aluminum that's processed. It's 1.5 tons of alumina or red mud. And this reminded me a lot of some deep diving I did into the world of coal mining with another recent guest, Isabel Reddy, who wrote the book That We Remember, which was a fictitious depiction of a coal mine disaster that happened when a slurry collapsed and, buried a town in Appalachia. So, there are examples from every type of mining where you can come up with something like this. So, how hard is it to deal with this red mud? How toxic is it, if it's toxic? And then what other toxic waste really comes up from its mining and processing?
Yeah, so red mud has a lot of iron in it, because that's one of the reasons it's red. Because when you process the aluminum, what's left often is the iron salts. Um, so it's not toxic in the same way as like you would have mercury or lead or cadmium contaminated or arsenic contaminated mines, which are there in many parts of the world. So the toxicity is not of that level. But the problem often happens is that the consistency of the red mud is such that it has to be stored in these kind of dams and impoundments. And so if there's like excessive rainfall or you have some earthquake, you can have a massive disaster where the red mud will just go into the rivers, and it will just choke out fish. Uh, and so you get a lot of danger. And that happened like in Hungary. There was a terrible disaster on the Danube where that happened. So that kind of
That was not that long ago. What, 2010? Is that right?
That's right. So, within the last, and this has happened also with iron ore mines. It's not just aluminum. In Brazil, we had two terrible disasters with iron ore tailings, and that led to, like about over 150 people killed in one. And and then also just like 500 miles of river areas damaged in terms of agricultural land. And also those are the kinds of things we have to be mindful of. And there is an effort at the United Nations. There was a global tailings review that was conducted. Tailings are the mine wastes, which are often stored in these dams and impoundments. And that review was jointly conducted by the industry and the United Nations, and they've come out with a series of safeguards. Hopefully, those will be implemented to reduce the chances of this.
Yeah. Well, I think there's really no way to get there without some form of regulation. So when we see more deregulation happening in the United States, I get really nervous because you see things like this. There will be bad actors. And when you're talking about a natural resource that is sold as a commodity, like, oh, well, oil is this and aluminum is that, you know, a penny savings on a pound is going to be quite something for that company. So we need regulations to make sure that the bad actors don't take over in certain arenas. And so that's where I am a proponent for regulation. Now, I know as all of these things, even if they are abundant, are limited resources, and we only have so much non arable land to explore, right? We also know that we need to set aside more land so that it can rest and recover and rewild, sequester carbon, do all the things that it needs to do for us to have a healthy planet. So many miners and well have been looking to the deep sea floor for these resources. You do talk about this in Soil to Foil as well, because apparently you left no stone unturned when it comes to the topic, which I really appreciated. So what are your thoughts, generally speaking, about going to our ocean floors for mining of minerals, whether they be something like aluminum, or even in the case of another recent exploration? Norway in January of 2023 reported that they found one of the largest stores of chromium in existence in the seafloor that they control, quite possibly worth more than their oil reserves ever have been, which is quite something. So we know there's going to be more continual exploration of our seafloors. How safe is it? How can we make sure that we aren't thoroughly degrading these other environments that, you know, need to also have a level of health to survive and thrive?
No, absolutely. I mean, ideally, we would not have to go to the deep sea or underwater generally for resources, because it is a less controlled environment than on land. But unfortunately, because of resource scarcity and continuing demand, we have done that with oil and gas, particularly, where so much of oil and gas is extracted now underwater, particularly in Norway. Actually, most of Norway's oil and gas is in the.
And why is Norway so rich? Because they happen to negotiate the split of what is considered their waters versus the UK is like directly at the halfway point, I think.
Yep. So most of that, and Norway is otherwise considered a very green country on its land, but because they were able to have a lot of the externalities of their extraction rents offshore, and now they have $1 trillion sovereign wealth fund, which means that Norway's entire population in perpetuity is essentially millionaires.
That's why social programs in Norway, I mean, doctors and people who work at the rental car counter, at Sixt, they could be earning close to the same amount of money, you know what I mean?
That's right. So that that's those are the kinds of questions. I would never say just like blanket no, never, because Norway is an example of how you could benefit a country if you did it in a certain way. Of course, there was some harm which came from it, but you have to balance the costs and benefits. So with deep sea mining, also, right now, my interest in this has been because many small island developing states see this as an opportunity for them to have resource rents without having an impact on their land. Many of these are vulnerable countries like Nauru or Tonga or Kiribati. And they may not even be able to have much tourism because of their geography, whereas other small island states like Fiji have very robust tourism. So there's disagreement among the small island states about this. Like Fiji doesn't want deep sea mining, but you have countries like Tonga and Nauru which have invested in it. We have an international governance system around deep sea mining, which we do not have actually for terrestrial mining. So for deep sea mining, there's a UN body called the International Seabed Authority, which regulates deep sea mining. Right now, we have no active projects. It's still in exploration phase, and there's a lot of opposition to it. But I think the opposition should focus on the science rather than just emotions. We have already gone that way once with nuclear power, where emotions uh, unfortunately led us down a path, which is why we are currently in the climate predicament, partly because we started to downscale nuclear too fast, even though the infrastructure was already there. Even in your own state, in California, they had to Diablo Canyon had.
I have read all the controversies around that as well, and, not every situation becomes Chernobyl, so, yes, there are leaks that occur. Fukushima, Japan is an example, but you know what? There you're able to contain those challenges, adapt the technology, get better at what you do, and if we had remained focused on that for the last 50 years, where would we be today? Probably more abundant energy without nearly the scale of climate problems that we have today.
Exactly. So with deep sea mining, I would be cautious, but I wouldn't just say no way, no how, never, because what's the alternative? Well, nickel, if the nickel demand continues to rise and we do not have nickel recycled in demand as much as we do, then what will happen? We'll open new nickel mines on land, and where will they be? Well, one of the big nickel mines currently is in Indonesia, which is the world's largest nickel producer, and that nickel is being processed and the waste is being dumped in the coral triangle, which is also the ocean, but it's a very high biodiversity part of the ocean.
Right, so then you end up damaging an ecosystem that is critical. Yeah.
So there are trade-offs. There's no free lunch in the universe, and we just have to figure out which trade-offs we are willing to take.
Well, and I think this is another argument then for why using aluminum more and investing in its recycling through programs is so key because it is so recyclable, reusable without degrading with time. And that's a state for really all metals. So if we can improve our reuse of it, I mean, granted, unless it rusts, right? Like iron will rust. So you need to make sure that it's, taken care of. But we can get to a situation where we don't have to rely so much on extraction of these resources if we're able to reuse the resources that we've already extracted and process that. So, I mean, I think it's just so important that we think about these things. The part that concerns me with our ocean is ocean floor degradation, ecosystem challenges, but also what happens insofar as noise, because there's even been conversation around how much noise can the whales and the other pinnipeds really take, right? So, I don't mean that whales are not pinnipeds. I mean whales, pinnipeds, so sea life, you know, any of the dolphins, any orcas, all of these animals that live in land that communicate via their sound. You start talking about drilling into seabed, there's going to be noise. Um, I'm a scuba diver. I dove on Hawaii when they were practicing some war games, and you'd hear these constant beeping deep underwater, and it would get to the point where I was annoyed, and I only had to spend an hour underwater, right?
Yeah, there's a lot, there's a lot which has to be done on research around these issues, but I mean, the deep sea is a little different from, like, we're talking about 10,000 feet under the ocean.
Oh, yeah, I'm not diving in that, but sound does travel, and the human ear can only detect so much, but, these sea animals, they have different organs.
We have to be, I mean, there are plumes which will come out, and there, though all the science needs to be clear on what will be the impact, but also we have found that marine life is often far more resilient than we had anticipated. They have to endure volcanic eruptions underwater. They have to deal with a lot. I mean, I think fishing is a far bigger threat, to be honest, than what may happen with deep sea mining. And I feel also oil extraction underwater is far more risky. in terms of catastrophic impact, as we saw with Deepwater Horizon in the Gulf of Mexico. Deep sea mining would not lead to some huge explosion because you're not mining, flammable materials. Whereas,
Yeah, and liquid. I mean, you're talking about solid state
yeah, you're
material.
just picking up what we're talking about right now is basically these polymetallic nodules, which are lying on the sea floor. So it's like scooping them up and taking them up. Yes, there will be impacts. We have to manage them. But unfortunately, the activism around this has put forward a lot of very uh, misleading information. And yeah, I see they're well intentioned, their heart's in the right place, but they need a systems view. They have to figure out, if we don't do this, what will be the impact? And I've said to the industry people on this, like, ultimately, if there's going to be mining in the deep sea, we have to reduce mining on land. You can't have both. And there has to be international governance to make sure if there is deep sea mining, that the total mining extractivism doesn't increase, because that's the last thing we want.
I 100% agree with that. And I do think that's a good point too. When you talk about identifying a node that you're essentially removing. So it means breaking it free and bringing it to the surface at that point,
Yeah,
which is different than, sticking a drill bit deep, deep into the ocean floor and then having a giant spill that impacts all life right
yeah,
on the surface. So, yeah,
indeed.
I mean, oil has been bad actors in many ways.
Yeah, and gas too, because the gas is explosive. I mean, it's really the methane releases underwater, they can cause a lot of problems. So, plus they add to greenhouse gas emissions.
Yep. Well, I know that this is late in the interview, but I wanted to just ask you a final question about just your belief behind the UN SDGs. Um, are we going to be able to deliver on the overall sustainability goals and keep climate collapse from occurring?
In terms of the SDGs overall, the targets, we are not going to meet all of them, but we are, I think, on a good track with some of the SDGs around particular targets. On what the SDG 12 is, the one I'm focused on a lot, which is sustainable production and consumption. So, for example, reduction of food waste, that is one which we can meet the target of, in my view. But there will be others where, with climate action, we clearly are not going to meet the targets overall. Um, and we'll have to adapt. I think it's very clear that now we are going to move towards an adaptive approach, because mitigation has to still continue, but we cannot now plan the future with just mitigation as the primary. And 90% of climate financing until like 3 4 years ago was going for mitigation, only 10% for adaptation. I think that's going to change.
Yeah. Well, adapting is critical. I mean, I will tell you, we have been hit here on the central coast of California with fires and floods. And I got evacuated from my home because of fires. I had friends lose their homes, lose everything really. And then I had flooding on my property, not once, not twice, but 3 times in a year. And so, and I'm on a hill. I thought I was safe. We never experienced this in the 13 years I've lived here, right? And then suddenly it all happened. So, the amount of water we get in a shorter period of time, how saturated the roads got. I saw, even asphalt buckling on the road just down from me because the water got so it saturated the soil so much that it lifted up.
Yeah. No, and the other that's exactly the kind of point I raise, is that this is so close to people. When people say like, "Oh, we don't know whether the climate is changing," I say, "Well, that's fine. Even if you don't believe in anthropogenic climate change, you are seeing the changes, whatever may be causing them. So let's figure out to adapt." Yeah, and so with sea level rise, for example, it's patently obvious that it's happening in many places. There's just no denying it. Now, whether you think it's a natural process or not, you've got to adapt. Miami better adapt. Amsterdam better adapt. You need managed retreat.
Brooklyn was completely flooded last week.
There should
So
be no controversy on it. That's what I find so puzzling. It's not a blue-red issue. You adapting it's something like you just have to figure it out.
So I think helping to change our mindset on that is critical because when you talk about moving from mitigation to adaptation, we're an adaptable species. That's what makes us so different from every other animal on this planet. And yes, they do adapt too. I'm not trying to downplay other animals' ability to adapt to their environments, but we construct homes and power plants and cell phones. It's completely different. Like, we should be able to adapt to this too. And so I fully am with you. I want to say how much I appreciate your work. I actually want to go and read your other books and invite you back to talk about them because I have to say I so appreciate the depth with which you covered this topic. I'm sure I could go back and read it again, cover to cover, and learn more. I did not feel like I was being dumbed down to at all. I mean, it's an academic text, but also um, so clearly thought out with historical references that help me see from more of a 30,000-foot view what the issues really are. And I have to say, as someone who considers myself a lifelong student, I really appreciated that. So thank you for your work. I hope that my audience will pick it up. I'm going to put it on my Amazon store list along with all the other authors I've featured just so that they can easily find it too. And I will be sure to link it on my site as well. So I encourage everyone to pick up Soil to Foil, Aluminum, and the Quest for Industrial Sustainability. Dr. Saleem Ali, thank you so much for joining me today.
Thank you, Corinna. Real pleasure.
Thank you for nerding out with me today. To learn more about Dr. Saleem Ali and his important work exploring how we build more sustainable industries, please visit his website, and that's saleemali.net. I will be sure to include that link on my website, along with much more in-depth review as well. So you can go to caremorebebetter.com for everything that we discussed today, including the earlier episodes that I referenced. You'll have a link to buy the book. You'll be able to review complete transcripts and additional resources. And when you sign up for our newsletter, you will also receive a 5-step guide to help you organize your efforts around any activistic approach you might be taking, or just act as a project management tool. I also include in there links to different climate action networks so that you can get involved and stay apprised of what's really happening out there. But at the same time, as Dr. Ali alluded to in this conversation today, it's important that you look at the whole picture and don't just become an activist with one idea without considering the rest of what's really going on. Now, if you enjoyed today's episode, I hope that you'll subscribe wherever that you're listening, and please write us a review. This simple action helps us to reach more people and climb the charts so more people can discover this show. And if you really loved this episode, I hope that you'll do something simple and share it with your community. You could just copy a link to the page or to the iTunes link or whatever works for you. Even download it directly onto a friend's phone that you think needs to listen to it. Now, I want to thank you always, now and always, for being a part of this pod and this community, because together we really can do so much more. We can care more. We can be better. We can even do a much better job of managing Earth's precious resources to build a better future that serves all people, not the few. Thank you.
Thanks for listening to Care More, Be Better, a podcast for social good. To make sure you never miss an episode, subscribe, rate, and review wherever you listen to podcasts, and share with your friends to help us reach more people and spread more social good.